Hello, welcome to MathPro by Bloom Academy. Okay, so in this video, we are going to quickly cover GCF versus LCM. GCF standing for greatest common factor. Greatest common factor. Okay, and some places this is called highest common factor. Highest, same thing. And then we LCM is what? Least common multiple. Common multiple. Okay, so quick, what do you need to know? You need to know factors, you need to know your divisibility rules, prime numbers, prime factorization, and prime factorization in exponent form. Okay, first question, find the GCF and LCM of 90 and 125. So two methods. Okay, this first method here, I'm going to use what I call the tree form. Okay, what I like about this method as opposed to this second method here we're going to do is that I can start with any factors with this method here. So 90, if I don't know my prime numbers, I can start with any two numbers that multiply to get me 90. I can start with 2 and 45, 5 and 18. The simplest one I see is 9 and 10. Okay, so I break 99 and 10. Okay, I write it down. None of them is a prime number, so I keep going. Then I break 9 down to 3 and 3. It's a prime number. So whenever I get a prime number, I circle it. And then 10 is 2 times 5. 2 is a prime number. 5 is a prime number. So when everything else here, on all the factors I get to prime numbers, I stop. So now, what do I have? 90 is what? It is 2 times 2 times 3 times 5. Okay. Let's see, is that right? No, 2 times 3 times 3. 2 times 2 times 3 times 3 times 5. I just wrote the smallest number first. In exponent form, this is what? 2 times 3 squared times 5. Okay. So I write it down over here. 2 times 3 squared times 5. And then I go to 125 and I break it down into what? Prime factors. 5 times 125, I circle my 5, and then 25 is 5 times 5. So this is 5 cubed. Okay, so I come here with my GCF and LCM. So with my GCF, I look, okay, I box every column and I look at the set with number, okay, number at every row. Okay, so here we don't have, this is blank, so I skip it. This is blank, I skip it. This is the only column that I will consider because it's got 5 on this row and then also 5 cube here. So it gets a number in each row. So that's the one I use, and I pick the smallest one. So 5 is smaller than 5 cube. So I come to this row here and I pick the smaller one. So GCF equals 5. I'm done. That's my GCF. Okay, so GCF, okay, I only use the column that has a number in each row. There's a 5 here, there's something here, I skip it, I skip it. LCM, I do not skip anything. Okay, so I come over here, okay, and I'm going to pick. So there's nothing here. We can write this as 2 to the power 0. This is also 3 to the power 0. Okay, there's nothing here. We get to the power 0, which is 1. Okay, so I come here and each column I pick the highest one, or the higher one in this case. So I pick 2. I go here. I'm not going to throw anything away. So I go here and then I pick 3 squared, and I come over here and I pick 5 cubed. And I'll say that is my what? LCM. And then if I multiply, I think I get 2,250. So this is my LCM, that's my GCF. So you've got it? Okay, so there is nothing here, the same as writing 2 to the power 0 there. Okay, so with GCF, what do? I only consider the column that has everything on each row. And this is one. So I skip this and I skip this. With LCM, I don't throw anything away and I pick the highest one. So here's 2. I pick the 2, 3 squared. And when I come to 5 and 5 cube, I pick the 5 cube. GCF between 5 and 5 cube, I pick the smaller one, or the smaller, I pick the 5. LCM, I pick the higher one. I'm done. Method 2. This method, I have to know my prime numbers. Okay, I have to know my prime numbers. So I write 90 and 125 here. I write it, and I find a prime number that divides both of them. 5. 5 divides 90, 18. 5 divides 125, 25. Then I look at 18 and 25. No common factors. You see that? No common factors. I stop right there. For GCF, I'm done. As soon as I have no common factors between the two, I stop. Okay, to find the LCM, I have to keep moving on. So GCF, I'm done. This is my GCF, no common factors. LCM, I got to keep going on. Okay, so 18 and 25, I find a number that divides any one of them. So 2 divides 18, I get 9 and 25. I have to keep going. They don't have any common factors, but I have to keep going. Okay, 3 divides here, I divide it again. I get 3 and then 25. I keep writing it. I don't have anything to divide it. Okay, so now I end up with what? 3 and 25. What do I do? Because here, I should have to put another 3 over here. Right? Is that true? 3 divides here, 3, and then 25. 3 divides here, 3 divides here, 125 again. Then I write 5, 125, and I divide again, 5, 1, 1. And I'm done, sorry. So what do I get? What do I get here? I have 2 times 3 squared times 5 cubed as my GCF. So GCF, I keep going, okay? I do not stop. Okay, let's do another example. Find the GCF and LCM of 20, 24, and 70. Okay, again, I break it down into prime factorization, right? 2, 2, and 5. Okay, and then I come write 20 is equal to what? 2 squared times 5. 24, I break it down into prime factors, and I get 2 times 2 times 2 times 3. So it is 2 cubed times 3. And then finally, 70 is 7 times 10. 7 times 10, I circle my 7, and then it's 2 times 5. Okay, so I write numbers under each column. This has become 2 times 5 times 7. Okay. With my GCF, I look at it. What am I going to do with GCF? GCF, okay, so this got a number in each row. There's a number here, there's a number there, there's a number there. That's the only column that has number on all 3 rows. That's the only one I'm going to use. I skip this, I skip that, I skip that one. And I pick what? The smallest one. So GCF equals what? 2. What about LCM? I do not throw anything away. I will consider every column and I pick the highest one. So this column here, I pick the 2 cube right there. The 3, okay, there's only 3 here. I pick the 3. There's a 5, there's a 5. They're of equal value. So I just pick one of them times 5 and then here times 7. And that is my what? LCM. Okay, what about this method? This method here too, I write this number in a row, okay? Then I have to know my prime numbers. So I find a prime number that divides all 3. So it is what? 2 divides here. And this is where your divisibility rules come into play, okay? Number that ends in the 0, this ends in the even number, so I start dividing by 2. So this is 10, 12, 35. See these 3 numbers here? They do not have any common factors. So I stop for GCF. I'm done. The GCF of these 3 numbers is 2. See, like, it's the same thing that I got over here. GCF is 2. Okay. But this method here, the tree method here, I can start with any factors and I keep going. With this method, I have to know my prime numbers. So here, I've got to keep going. So I have to find, okay, so 10, I can divide 10 by 2. That's what I would do. 10 divided by 2 is 5. 12 divided by 2 is 6. 35 doesn't divide, but I'll write my 35 there again. I keep going. Okay, I can divide, I can put 2 here again, and I can divide this by 2, and I get 3. 5 and 35 do not divide, but I just write them down. Okay, then what? What do? I find a number that divides either 5, 3, or 25, 35. Let's say 3 divides, doesn't divide here, but it divides 3. So I put 1 there. So 5, 1, 35. Okay, what do I come? Now I come to this line here, right here. Then I start dividing by 5. 5 divides here 1, 1, 7. Okay, and then this line here, okay, I can divide by 7 again. So this is 1, 1, 1. So with this method, I keep on going until I get all ones. And my LCM now is multiplication of all these numbers here. That's my LCM. Okay, so GCF, I stop. LCM, I keep going on. All right. And so, there you have it. You know the difference. And then, sorry, this was 5 over here. 3 divided, 5, 1, 5, and then 5, 1, 1. And I'm done. Okay. All right. So that's a quick review of LCM and GCF. And for IXL practice, write these down. Go ahead and practice. Pause the video. Okay. Review it. See if you get the same answers as I did get. If not, retry until you master it. Okay. We'll be using this to solve word problems. All right. Okay. Keep on applying yourself very well. And all things being equal, what do I say? You shall bloom. Have a great day.